Hey guys, my name is Frank, and this is the Poth on Programming video log, part 4 of how to make a tile-based platformer in pure HTML5 and JavaScript. In today's video, I'm going to show you, the aspiring game programmer, how to add pixel-perfect, professional-quality, tile-based collision detection and response to a platforming game. So stay tuned to find out how it's done. In this video, I'm going to talk about what's changed since part 3, then I'm going to go over the 3 main components of my collision system. There's the broad phase, the routing function, and finally the narrow phase. If you have any comments or questions, put them in the comments section, and if you learned something, like this video so others can find it as well. Now let's get into the video. Let's take a look at what's changed since part 3. So this is part 4, it looks just like part 3 for the most part, except now I have collision detection and response between my player character and the game world. So as you can see, I'm moving smoothly across the tops of the tiles. I'm jumping up along the sides of the tiles. I'm not getting hung up on any of the edges. Anywhere I can jump through the bottoms of these platform tiles. Basically, I have pixel perfect tile-based collision detection and response, and everything looks and works the way you would expect it to in a tile-based platforming game. So now that you know what the example is all about, let's take a look at what's changed in the code. So the only 2 files that have changed since part 3 are the game file, which holds the game class, and the display file, which holds the display class. Display had a minor change since part 3. If you remember part 3, I had an issue with the export values for my tile map because I used the tile map editor, and all the values were offset by 1. So I just changed this function and I changed my tile map values to what they're supposed to be. So I got rid of the offset. As you can see, I have the comment no longer subtracting 1. Take a look at part 3 so you can see what I'm talking about. Also in here in the draw player class, I changed math.floor to math.round in this line and this line here. And the reason is because it just rounds my player to the appropriate spot that he's going to be drawn in more smoothly. So those are 2 really minor changes in the display file. Inside of the game file, a lot has changed. I've added the collider function. I've added my collision map, which is this guy right here. A collision map is different than the graphical map for the tiles themselves that you see on the screen. These are for the collision shapes. Down here, I've amended my collide object function inside of the world class to do the broad phase collision detection and response that are these functions right here. Then I've also added the collider class. The collider class takes care of the routing function as well as all of the narrow phase collision methods like collide platform bottom. So collide platform bottom would be called whenever you physically collide the top of the player with the bottom of a platform. So I'm jumping up, and collide platform bottom is firing every time my player hits his head on the bottom of that tile there. So that's what that does. Then I've also added a base class for the player object called object, and that's nested inside of game.world. The object is basically just a simple rectangle class, and I'm going to talk about xold and yold and why we need those later on in a different part in this video. But basically the object class is just the superclass of the player class. Now basically the player is going to inherit all of these values from object, and it's going to get all of these neat little helper functions to get the different sides of his rectangle. So that's all that does. And then down here you can see I'm actually extending the object class inside of the player constructor, and down here I'm actually extending the player prototype off of the object prototype with object.assign. So those are all the changes in part 4. Stay tuned for the rest of the video. There are 3 main components to this approach to tile-based collision detection and response, and those are the broad phase, the routing function, and the narrow phase, and they're all centered around having a collision map full of collision tile values. Each value represents a different shape or collision shape. So for instance, if I hop over here, I can jump through the bottom of this tile but not fall through the top of this tile here. I can collide with the bottom, I can collide with the right side, and I can collide with the top of that as well. This tile over here, these 2, I can collide with the left side. So all of these tile values correspond to collision shapes that have different sides. So the broad phase gets what tile my player character is standing on. It determines what the value of that tile is that my player character is standing on, gets that value from the collision map. It then hands that value as well as the player object into the routing function. The routing function checks the value in a switch statement, and it says, okay, well, let's check. For instance, I'm standing on top of tile 1 here. This is tile 1. So the routing function would say, okay, you're colliding with tile type 1, and for tile type 1, I'm going to call a certain set of narrow phase collision detection and response methods. So the broad phase determines what the tile value is, the routing function determines which narrow phase functions to call, and the narrow phase does the final collision detection and response. And that's how the system works. So stay tuned, and I'm going to go into the code that makes that stuff work in detail. Alright, so now I want to talk about the broad phase collision method, and that is going to be the collide object function, which is located inside of the game.world class. So I'm going to come down here and show you what this broad phase does. The whole function, all it does is first it checks for collision with the outsides of the world, and that's going to be this right here. That's from part 3. That's pretty simple stuff. And then the other thing it does is it checks all of the different corners, all 4 corners of our player character. So I have these 4 chunks of code. I have one here for the top left, I have one for the top right, one for the bottom left, and one for the bottom right, and that's the end of the function. So this is the entire broad phase, just these 4 chunks, and this chunk up here, which does collision with the boundaries of the world. So let's take a look at the first chunk that tests for broad phase collision with the collision map with the top left corner of our player character. So what these are a row and a column value inside of our collision map. So top is going to be the row that the top side of our player is in, and left is going to be the column that the left side of our player is in. So this is going to be the top of our player, this is going to be the left side of our player, and this is going to be the row that the top is in. Now if I move the player over here, this is going to be the row that he's in. And if I check the left side, this is going to be the column that he's in. If I move him over here, now the left side of the player is in this column. So pretty simple. The math that we use to get the row and column and convert it from the physical XY position of the player to the one-dimensional index or of a row or column value. It's not really one-dimensional, it's two-dimensional, it's just simplified. Basically, you just get the top of the object, which is the Y position of the top of the object. You divide by tile size. That gives you the row of the top. And then you do the same thing for the column. You just get the left side of the object, which is right here. You divide it by tile size. That's going to give you the column value. And then you're going to go ahead and convert those, the row and the column, into a index inside of our map array, our collision map array. And you just do that by multiplying the row by the number of columns inside of the collision map. Ours was 12. And then you add the column that the player is standing in. So that's the row of the side of the player multiplied by the number of columns in the collision map plus the column of the side of the player. Pretty simple. And then you go ahead and you hand in that value as well as the row and column positions of the tile multiplied by tile size to give you the actual X and Y position of the tile. So for instance, if I was going to get the top left of my player, that would be right here. He's inside of this tile. The top and left values multiplied by the tile size is going to give you this position right here, which is going to be the X and Y position of the tile. So we're going to hand all that information into the collider's collide method, and that's going to be the routing function. You're going to hand in the value, you're going to hand in the object, you're going to hand in the left side of the tile, and you're going to hand in the top side of the tile. You're also going to hand in the tile size. And then you just go ahead and you do this for every corner of the player. So we just did the top left. Down here we're going to do the top right. Then we do the bottom left. Bottom left, there we go. And we do the bottom right. And we just do that for all four corners. Now you might be thinking, well, you're redefining some values that you're reusing. So why not just define, for instance, here we go. Let me find a good example here. Right. So this is checking the top right corner, right? This right here. And this is checking the bottom right corner. Well, I'm defining right 2 times, but why would I do that? Well, the reason I'm doing that is because here I'm defining right, and I'm checking for collision. If I have a collision and I respond to it, my player character is going to move. And right, as I defined it here, might not be the same anymore. So down here, when I'm getting the right side of the player again, I'm not going to want to use this old value for right. I'm going to want to get the right side of my player again because it might be different than it was when I checked collision with the top right. So when I check collision with the top right, if there is in fact a collision up here, it's going to move my player. And then when I check, oh, this is the top right. I keep getting confused there. But then when I check the bottom right, if I moved, that value is going to have to be redefined to get the appropriate new location of the player's right side after he had collision resolved with the top right corner. So this is the broad phase. It's not as complicated as you think. It's really simple. The math is really simple. You're just getting a value out of an array based on a player's column and row, or row and column rather, and then you're handing all that information into the routing function. We're going to take a look at the routing function in the next part of the video. Now let's take a look at the routing function. So I'm going to come down here to the routing function, and that is going to be in the game.world.collider class, and it's going to be called collide. So the collide function is my routing function, and all it does is it takes the tile value, the object, and the tile's x and y position, as well as the tile size, which is the tile's width and height, and it takes all that from the broad phase and it hands in the value of the tile into a big switch statement, which then routes you, and that's why I call it a routing function. It routes you to the appropriate narrow phase collision methods, and it also does some tweaking to the tiles. So for instance, case 1, if I move my player down here, I'm actually going to be standing on a 1 tile. I know for a fact this here is a 1 tile, and it's going to call collide platform top, and it's going to hand in the object, so that's going to be my player character. It's going to hand in tile Y, not tile X, because we don't need it in this case. We just need to know what the top of the tile is going to be. Now, if I want this to be a little bit lower, say I want to make a half tile, I'm just going to hack this right now, but I'm going to put in +8, and I know for a fact that 8 is half of my tile height. So that's going to be, oops, didn't mean to do that. That's going to be my change that I made. I saved my file. I'm going to refresh my screen. Now, as you can see, all the 1 tiles that I'm colliding with are going to have half height. So this tile right here, I'm now going to be colliding with a value that's a little bit lower. Interesting. So I can take my narrow phase functions and I can tweak them a little bit inside of my routing function, and that's going to give me the ability to create a whole bunch of different tile types however I want. So all the different shapes are going to be defined basically inside of the routing function, and all it really does is gets the tile value and links it to a certain set of narrow phase functions. Let's take a look at, let's see what I got here. Let's take a look at something a little more complex. First, I'm going to have to see what tiles are what, because I can't think right off the top of my head what those values actually stand for. But if I look at my map, I'm going to come over here to a 13 tile, and that looks to be at the left side of this T right here. So 13 is going to be, oh wait, I forgot to refresh my screen. Let's refresh and get functionality back to normal. So 13 is going to be this tile right here that I'm standing on now. So let's take a look in the routing function at the 13 tile. Alright, here we go. It's going to call the methods collide platform top, collide platform left, and collide platform bottom. And the reason for that is because I'm going to collide with the left side of this tile, collide with the left side, maybe if I can actually hit it, collide with the left side, I'm going to collide with the bottom, and I'm also going to collide with the top. So those are the 3 sides that I'm going to be able to collide with if I happen to meet a tile with a value of 13. Now, the reason I have some of these functions nested inside of if statements is because I can only collide with one of those sides of a tile at a time. So I can only collide with the top, and if I do, I can't possibly be colliding with the left or the bottom. Certainly not the bottom if I'm coming from the top. How would I collide with the bottom? So I use these if statements to early out of my routing function and not have to execute checks for these other 2 functions, which is great because for any given tile, we're only checking collisions on sides until we actually do collision, and then we just exit out and we don't have to check the rest of the collision. So collide platform top is going to be in this if statement, if I collide with platform top, then I'm no longer going to have to check for colliding with the left side or colliding with the bottom side of the tile. Now, inside of my narrow phase, my function returns true if I do in fact have a collision and it is resolved, and it returns false if no collision was detected and nothing was resolved. And if that's the case, if it's false, it'll just jump down to this next narrow phase collision method, call that. If there's no collision there, it will jump finally to the last method in the case and call that. And if that doesn't return true, then there is no collision and nothing gets resolved. So that's the routing function. Pretty simple. That's how it works. In previous tutorials on how to do this system, this tile-based collision system, I used an array and I used object references to get these, but actually it's much faster to use a switch statement. So that's why I made the switch to a switch statement. Pun intended there. So anyway, next step, onto the narrow phase. Now let's look at the narrow phase, and that is going to be farther down inside of the Collider class's prototype. So inside of the Collider class's prototype, I have 4 functions, and those are collide platform bottom, collide platform left, collide platform right, and collide platform top. And awesomely enough, with these 4 functions, we can do collision detection and response with all of the different tile types. Basically, any tile that has 4 sides, we can take these 4 functions and combine them to get all kinds of different combinations, up to 15 combinations, which is as many combinations as you can have with a 4-sided tile. So let's take a look at, let's see here, collide platform top, where I think I was on already. Let's take a look at collide platform top and see how this actually works. So from the routing function, you're going to get the object and you're going to get the top side of the tile. So the top side of the tile is just going to be whatever the top of the tile is that you're standing on. So right now I'm standing on this tile. I have my object, I have the top of my tile, and we're just going to run an if statement that checks to see if the bottom of our player character is greater than the tile top, and if it is, then we run this code. But wait, there's more. There's an and in here, so we've got to see what that is too. We're also going to check to see if the bottom of the player from the last frame of animation is above the tile top. Now, if you didn't include this, it would still work, but it would not work as smoothly as you see here. So let's go ahead and comment this out and see what happens when we don't use the old position from the last frame of the player character. I'm going to comment that out. I'm going to save. I'm going to come in here. I'm going to refresh. And now let's see what we get. Everything might work perfectly, but oh, wait, how about that? I just jumped right through that tile. Now, the reason for that is when I jump up, the top left and top right corners of my player are going to enter into this tile space. The broad phase is going to detect that. It's going to hand the information to the routing function, and the routing function is going to call collide platform top. Now, collide platform top, without doing this check on the last position that the bottom of the player was in the last frame of animation, without that, it's just going to check to see, is the bottom of the player greater than the tile top? And if it is, set it to the top of the tile. So that's what's happening. When I enter into the tile, it detects that the player was below the top of the tile, and it just sets it right to the top. So that's the functionality you're going to get without this. When you add this in, basically what's happening is it's saying, hang on, let me refresh real quick. Basically, it's saying, okay, the bottom of my player may be inside of this tile, but if on the last frame it wasn't up here and therefore entering into this tile between frames, so on frame 1 he's going to be here, on frame 2 with the force of gravity he's going to be down here inside the tile, he's going to be entering in through the top, and collide platform top is going to detect that inside of this if statement because the bottom on the current frame is going to be below the tile top, and the bottom on the last frame is going to be above the tile top. So that's going to be true, and then we're going to get the appropriate response that we expect, and we're no longer going to jump through the bottom of the tile and get that kind of glitchy looking collision response. So Now let's take a look at what happens after we do that, after we collide with the top of a tile. So I'm going to collide with the top of my tile here. This is going to be true. The bottom on the current frame is going to be slightly below. The bottom on the previous frame is going to be above. And what I'm going to do is I'm going to set the bottom of the object. I'm going to set this bottom of the object to the tile top. And I'm going to subtract this little value here. And I'm going to get into why I subtract that value in a minute. I'm going to take a look at another function because that better explains why I do that. I'm going to set y velocity to 0. This way gravity doesn't keep increasing and eventually pull me through the tile altogether. I'm going to set jumping to false so I can jump again. And I'm going to return true so I can tell the routing function not to do any more narrow phase collision calls. So now let's take a look at this little value and see what it does. But I'm going to do it in the context of the collide platform left function because that also has a similar problem. Collide platform right and collide platform bottom don't have this problem, and it has to do with rounding. So let's just comment this out and see what happens. But first, I'm going to show you the desired functionality. So right now I'm colliding with the left side of these two tiles, and it's calling collide platform left to do that collision resolution. So as you can see, I can jump up and down, and it's as you would expect. I'm jumping up and falling down. Nothing is broken yet. So let me comment this out and break the code. I'm not really breaking the code. It's all going to work the same. It's just not going to have the desired effect. I'm going to refresh my screen, and I'm going to come over here, and I'm going to do this again. Now when I jump, I land on top of the tile, and the reason for that is because when I'm falling down, I'm actually going to be in this tile space with the right side of my player. So the right side of my player, when I'm falling down into this tile space, is actually going to be in this tile space. Just looking at it with a naked eye, it looks like he's fully inside of this column, but really his right side is just barely inside of this column over here. So unless we subtract that 0.01 or some tiny number, doesn't have to be 0.01, it could probably be 0.1 or 0.001 if you prefer. Because we subtract that, we are pushing the player character out of this tile into this column, and he's no longer touching this after he enters or exits collision with the left side of this tile space. So let's refresh and see what that good functionality looks like. Now I'm colliding with the left side of this tile right here. It's pushing me out of collision, and it's actually pushing me out of the tile space entirely by 0.01 pixels. So when I jump, I am fully inside of this column as you would expect, and I'm no longer going to be colliding with these tiles unless I press right on my keyboard and move the player into them. So that's why I have to subtract that little value. Now, before I stop talking about the narrow phase collision, let me just talk a little bit about object.getOldRight and how we actually do that. So basically all we're doing is on every frame, we are saving the last frame's player position, and we're getting the new frame's new player position. So where that happens is inside of the player object. Let me actually come out here and look so we can actually see the code a little bit. The player class now extends the object class, and inside of the object class we have, this is the object class right here. Inside of this we have some information to describe a rectangle, and we're also going to have the xold and yold values. So keep that in mind. We have a x and y location, and we have the x and y location from the previous frame of animation. So if I come down here to the player class, and I come down here to his update function, this is where we're going to be keeping track of this. Xold and yold are going to be updated on every frame of animation to equal that frame's current x and y position. And then we're going to update x and y to be as fresh as possible in the new frame. So we're basically just keeping track of the player's old x and y position from the last frame and his current x and y position from the current frame. And that allows us to calculate his angle of trajectory. And we can see, based on that trajectory, if he was above a tile before he entered into it. And that will give us the ability to get rid of that broken functionality that you saw where I would jump up and just almost teleport through this tile and sit on top of it. So that's why we have to keep track of this. This is also great for interpolation, which is something really useful for smooth animation, but I'm not going to talk about that in this video. Anyway, that is the narrow phase. It's really simple. The functions are all really simple. If you just take a look at the source code, I urge you to go to the link in the video description and check that out on my GitHub page. And that's it. In this video, I talked about how to implement tile-based collision detection and response. You can find the working example and source code for this video linked in the description. As always, feel free to hit me up in the comments below and be sure to like and subscribe if you want more videos like this one. Anyway, thanks for watching and I'll see you guys next time.